All right, let's look at exercise number 1. A warehouse is keeping track of its inventory of cardboard boxes. At the beginning of the month, they had a supply of 1,275 boxes left. They used boxes at a rate of 75 per day. So the first question is, how many boxes are left after 10 days? So at the beginning of the month, they had a supply of 1,275. So 1,275 is their starting number. And then they use at a rate of 75 per day. So every day they use 75. And we want to know after 10 days, how many do they have left? Well, negative 75 times 10 is negative 750. We're going to add that to 1,275. That's the same thing as 1,275 minus 750. So the answer is 525 boxes. So which of the following linear equations correctly models the amount of boxes left in after D days? So let's look at the what we have here. We had negative 75. So negative 75. This is the only one that has a negative 75, showing that you're using 75 boxes per day. And you start with 1,275. So letter C, if the warehouse needs to order more boxes when their supply reaches 150, how many days can they wait? So we want to know if 150 is the total that we want to get to, and we have negative 75 times D plus 1,275. So we need to solve for D. So subtract 1,275 from each side. And we get, so 150 minus 1,275 is negative 1,125 equals negative 75D. Divide both sides by negative 75. And the number of days is 15 days. So if after 5 days they start using boxes as a rate of 90 per day, how many boxes will it be before they run out of boxes? So first we need to figure out, after 5 days, how many boxes do they have left? So negative 75 times 5 plus 1,275. Well, negative 75 times 5 is negative 375 plus 1,250, or 1,275. And that's 900 boxes that they have left after 5 days. So the next part of this question is asking, if they now use 90 per day, so negative 90 per day, but we have 900 as our starting point. So how many days does this until you run out? So how many until it equals 0? So we're going to subtract 900 from each side. Negative 90D equals negative 900. Divide both sides by negative 90, and it takes 10 days after this. But how many days total? So we have our 5 and 10, and it's still, or this time it's going to be 15 days total when they run out. Exercise 2, the cost C in dollars of running a particular factory that produces W widgets can be modeled using the linear function. So C of W equals 1.25 times W plus 2,175. So how do you interpret the fact that C of 100 equals 2,300? Well, remember that this 100 is in place of W. So 100 widgets, right, because 100 was in place of W, is, remember if the equal sign means is, $2,300. Give a physical interpretation for the two parameters in this equation, 1.25 and 2,175. Excuse me. So 2,175 is money, and 1.25 talks about 1.25 per widget. So each widget costs $1.25, and there is a startup fee of $2,175. So what this is saying, that we're talking about cost. So there's a startup fee, there's an automatic fee of $2,175. If there were 0 widgets made, they would still have $2,175. That money could be like the rent for the building or just the cost that it is to run the equipment. And then each widget, the product itself, the materials, is $1.25 per widget. Biologists estimate that the number of deer in Rhode Island in 2003 was 1,028, and in 2008 it had grown to 1,488. Biologists would like to model the deer population P as a function of the years T since 2000. So represent the information we have been told as 2 coordinate points. So here's our first coordinate point. Time, or years, is always your x value. So 1028 is our y value, but it says since 2000, so that means 3. It's been 3 years since 2000 for our first one. And in 2008, it's grown to this. So since 2000, it's been 8 years, and there's now 1488. So calculate the change in P over change in T from 2003 to 2008. So change in P, so from 1028 to 1488. It has gone up, so the change in population has gone up 460 deer. And then from 3 to 8 has gone up, so the change in time has been 5 years. So 460 divided by 5 is 92 deer per year. So give a physical interpretation of the value you found in Part B. But, well, the physical representation is that every year the deer population increases by 92. Determine a linear relationship between the deer population P and the year since 2000. So we know that the population goes up 92 per year. But now we want to know, what is our starting point? So our starting point, if I plug 3 in for T and 1028, so I'm using my first coordinate point. Remember, we're finding the B, the y-intercept. So 92 times 3 is 276. So we're going to subtract 276 from both sides. And you get 752 equals B. So our equation is P equals 92T plus 752. So in the year 2000, there were approximately 752 deer. How many deer does this, well, I just answered that question. So approximately 752 deer, and it's the y-intercept. How many deer does the model predict for Rhode Island now? So we want to know, what is our population if it increases by 92 per year, but since 2000, we're now year 2017 plus 752. So 92 times 17 is 1564. Add 752 to that, and the population should be around 2,316 deer. Water is draining out of a bathtub such that the volume still left, G gallons, is shown as a function of the number of minutes, M, it has been draining. So calculate the average rate of change over 0 to 2. So our number of gallons from 0 to 2, 62 to 28, has decreased 34 gallons. And from 0 to 2 has increased 2 minutes. So 34 divided by 2 is 17. So it's negative 17 gallon per minutes. So calculate the average rate of change from 2 to 4. So 28 to 12 is negative 16. And from 2 to 4 is still up 2. So it goes down negative 8 gallons per minute. Why can we say that the relationship between M and G is not linear? Well, it's not linear because these are not equal. The rates or slopes are not equal. So since those aren't equal, it's not going to be a linear equation. What it would look like, so if this was our y-axis and this is our x-axis, what this is looking like is it's going to be more of like this or even like this.